Section 1.5 is talking about analyzing graphs. It's just looking at different points of graphs, telling what is happening at that point and what is going on really on your graph. So I'm not going to waste your time telling you really what it is. Just going to go ahead and jump into some random things that you're going to see. So looking at this graph, this question is asking you to analyze where the graph is increasing or decreasing or whatever it's doing. So it's saying which intervals the function is increasing or decreasing. So don't forget, well, read the function like you read a book from left to right. So starting from this function, or from the left, this is actually going down. Here it's staying constant, and then from there on it's going up. So I could say it's decreasing all the way up until right there. Well, that's -2 on the x-axis. So coming from negative infinity, decreasing from negative infinity all the way up to -2. This is just on the x-axis. Don't look at it in the y-axis, just in the x-axis. Because it goes from here all the way up to -2. Then I have from there up to 0. From here to here, it is constant. It doesn't change at all. So I'm going to say this is constant from -2 to 0. That's not the point -2, 0. That is from -2 to 0, just on the x-axis. And then it goes from there on. So from here, forever, it is increasing. So increasing from 0 to infinity. That's all you would have to put on analyzing that graph. We also have this concept of average rate of change that it'll ask you about. Average rate of change, all that really means is just the slope of something. So slope. Right? We know slope is m. This stands for m. So this is basically m. F of x2 minus f of x1. Don't forget f just stands for y. So basically it's saying y2 minus y1 over x2 minus x1. Well, hey, that is our slope formula. y2 minus y1 over x2 minus x1. The difference in the x's over the difference in the y's. So let's do look at an example. That's not an example. Get out of here with your blue banana monkey. That's more like it. All right, this one. Find the average rate of change. So the slope. All that means, average rate of change, just slope. Find the slope. If f of x equals 3x squared, 4x1 is 2, x2 is 6. So these are like points. So I have the point 2 something and 6 something, and all I'm doing is finding the slope between 2 points. You've done this before. So take 2, if you don't know the y value, take 2, plug it in. 2 squared is 4 times 3 is 12. So this is the point 2, 12. And 6 squared is 36. I shouldn't have done by 3. 90, 108. So 108. So really all this is y2 minus y1. So 108 minus 12 over 6 minus 2. 108 minus 12 is hopefully 96. Divided by 6 minus 2 is 4. 96 divided by 4 is 24. So your average rate of change from this point to the other will be 24. And that's how you write your answer. Last new concept of this section is even-odd functions. So an even function is basically talking about something like x squared, where it goes up in both directions. This is not always true. We cannot just always look at the graph and say that this is an even function or this is an odd function. We have to do tests. So our test for both of these is taking f of negative x and seeing what it comes out to be. If this comes out to be your original function after you plug in negative x into your x value, then this is an even function. If it comes out to be negative f of x, so basically if all of the signs change from your original function, then it is an odd function. Let's look at an example and see what the heck I'm talking about. Determine even, odd, neither. So it's going to be one of the three. It's either going to be even or odd or neither, obviously. Of f of x equals 2x squared minus 3. So in order to test even, odd, or neither, we're going to take f of negative x, just like we saw in our rules, and see what it is in your function. So if I plug in negative x wherever I see an x, so all it's doing is replacing negative x for x. 2 times negative x squared minus 3. Well, negative x squared is positive x squared, so really this is 2x squared minus 3, which is sine for sine exactly like your original function. So since it is exactly like your original function, we have an even function. And if you were to look at your graph, 2x squared minus 3 does something like this. Even functions also have a y-axis symmetry. Pretend like that says symmetry, not smooth or something like that. Yeah! Same sort of deal with this one. Determining whether it's even or odd or neither. I have f of x equals x cubed plus 2x. Just like any of these, if you're testing even, odd, or neither, all you're going to do is plug in a negative x where you see an x. So this will be negative x, cubed, plus 2 times negative x. Negative x to the third is 3 negatives multiplying. 3 negatives will come out to be negative x cubed. Negative x times 2 is minus 2x. Now notice in this one, the negative, well, that was positive. This one was positive, now it's negative. So all of the signs changed. Since all of the signs changed, this is an odd function. Odd functions will have origin symmetry. So you'll be able to turn the paper upside down, and it will look like the same exact picture. For something to be neither, say like if this came out to be x cubed minus 2x, such that the x cubed has the same sign, but the minus 2x has a different sign, this is a case where it would be neither. Okay, hopefully this video was helpful for you guys. I will see you in class. Ask me lots of questions. Otherwise, my hair will keep falling out. Unless I'm already old and bald and you guys are watching this video like 40 years after I made it. That would be interesting if YouTube's still around. All right, well, I'll see you guys later. Hopefully it is. Hopefully I am too. Bye-bye.